Welcome back to our YouTube channel. Today's masterclass focuses on Venn diagrams, a reasoning topic that consistently accounts for 1 to 3 marks in Gujarat's competitive exam cycles. We are bypassing basic intuition to move from absolute zero-level axioms to the advanced structures used in syllogism. Mastering this visual framework allows you to approach reasoning problems with a repeatable system, building a self-contained logic designed to handle the complexity found in GSSSB and GPSC papers. To understand this, we rely on a framework by mathematician John Venn. Every complex relationship reduces to just 3 logical states. The first is all, complete inclusion. The category of apples exists entirely inside the larger category of fruit. We see the same logic with geography. Gujarat maps entirely inside India. The second state is sum, representing a partial intersection. Consider teachers mapped against men. Not all teachers are men, and not all men are teachers. That overlapping center is the only valid zone for shared categories. The third state is none, dictating mutual exclusion. A dog and a cow share 0 logical crossover, leaving an empty gap. Regardless of how complex a word problem appears on an exam, its core architecture is built from these 3 atomic states. In competitive exams, word-based questions generally fall within a system of 10 universal cases. Most problems you encounter will adhere to one of these 10 geometric frameworks. Case 1 is concentric inclusion, tracking a second, a minute, and an hour. Each unit is entirely contained by the next. Case 2 maps separate entities. An apple, a chair, and a river have 0 logical relation, resulting in 3 disconnected boundaries. Case 3 illustrates 2 inside 1. This occurs when 2 mutually exclusive items are bound together by a broader category constraint. A table and a chair are exclusive items. A table is not a chair, but both are completely enclosed by the larger category of furniture. Case 4 uses 3 overlapping circles to represent fluid, multidirectional categories. If we map writers, teachers, and musicians, we see that a single person has the capacity to inhabit all 3 spaces simultaneously. Recognizing these geometric architectures prevents you from attempting to invent new logical structures while under the pressure of an exam. Case 5 is a configuration often used to trigger errors. It tests your ability to distinguish between partial and total inclusion. Let's look at this setup. The variables here are mothers, sisters, and females. Internally, we have a sum relationship. Some mothers are sisters, and some sisters are mothers, but not all. Externally, we have an all relationship. Both categories must exist entirely within the female boundary. Let's apply this to a simulation using dogs, pets, and cats. A common mistake is placing dogs and cats entirely inside the pet circle, assuming all such animals are domesticated. Because wild dogs and wild cats exist, these categories can only partially overlap the pet boundary. The regions outside the pet circle represent the wild population. Success in these questions requires sticking to literal category limits rather than making assumptions based on everyday conversation. Type 2 problems involve geometric data extraction. Here, the logical relationships are mapped to specific numerical values. This diagram displays our spatial variables. We have a triangle, a circle, and a rectangle, with numbers distributed across every intersection. We assign the variables. The triangle represents doctors, the circle represents rural areas, and the rectangle represents males. To find doctors who are rural but not male, first eliminate the negative constraint by removing the male rectangle and its data. Then, locate the exact intersection of the remaining categories, where the doctor triangle and rural circle cross, isolating the number 8. Consistently deleting negative constraints before searching for overlaps greatly reduces the risk of calculation errors in multivariable problems. We have now transitioned from intuitive guessing to a system based on John Venn's 3 axioms and the subtractive data algorithm. This exact spatial logic serves as the prerequisite for solving syllogism problems, providing the visual architecture needed to verify statements and conclusions. On screen is a challenge to test your application of these rules. Travelers, train, and bus. Apply the axioms we covered to these 3 entities and leave your answer in the comments. I will respond to the correct deductions. જો તમને અમારું કન્ટેન્ટ પસંદ આવે તો અમારી ચેનલને લાઇક કરો, કોમેન્ટ કરી દો અને તમારા CCEની તૈયારી કરતા મિત્રોને શેર કરી દો અને કોમેન્ટ સાથે સબસ્ક્રાઇબ કરવાનું બિલકુલ ના ભૂલતા, જેથી અમને આ પરીક્ષાને લગતા વધુ સારા વિડીયો બનાવવાનું પ્રોત્સાહન મળતું રહે. આભાર.